Because didn't it help that I explained that the whole thing's the sanctuary?
Yeah.
Think about it would be kind of tricky, wouldn't it, if the sanctuary was this shape, that kind of R shape? Oh, I should let you guys know. A way to find area of this shape would be to use calculus.
Oh, cool.
So yeah, that's one application of calculus is you can find the area underneath a curve. And it would entail figuring out an equation for this, but you could totally do that. And once you got the equation, you could do it pretty quickly you could use calculus to get the area, which is kind of fun. You can also use calculus to figure out instantaneous velocity and instantaneous speed. There's lots of applications with calculus. But anyway, are you guys cool with how we did that? One way to do it is to think of the wooded area as a trapezoid, and I believe that's how I wrote it out. But because these partial squares are cut perfectly in half, could you do it a quicker way?
I can count them.
Yeah, just count them up. Count them up. Okay. Well, I don't really think of the top one as a geometry example, but you can think of it, I guess, as like a line. Can you guys envision time as being like a line?
Yeah, sure.
Where you got earlier time and later time?
Yeah.
So you kind of think of it, yeah. Well, you can kind of think of this problem this way. It says that a train leaves a station every 30 minutes. And it says your trip to the office takes 18 minutes. Let me fill in some details. You're riding the train to work. Is everybody with me on this?
Yeah.
Or you're in a big city and you ride a train. Oftentimes, at least I think in New York, outside of New York City, the train is above ground, and then as it gets towards the city, guess what it does? It goes underground and becomes a subway, right? So you're riding the train to work, and once you get on the train, it's only an 18-minute ride to work. Is everybody with me on that?
Yeah.
But the problem is the train doesn't operate on your schedule, does it? But it's on a schedule where it says that it arrives or it leaves every 30 minutes. Okay? So sometimes your wait getting to the station is going to be 30 minutes, isn't it? If you get there right as the other train left, you're like, dang. And then, how long does that mean you're going to have to wait until you get to work? How long is it going to take to get to work?
48 minutes.
48 minutes, right? Because you're going to have to wait a full 30 minutes and then 18 minutes for a ride. So do you guys kind of have a vision for what's going on here before we continue?
Oh.
Yeah.
How do we know what time the train leaves?
What's that?
How do we know what time the train leaves?
We don't. And that's what makes this difficult. Yeah, we don't know. But it does say one morning we arrive at the train station at 8:15. So here's us showing up at the train station at 8:15, right? All right, there's us. It says you need to be at work by 8:45. Okay, you need to be at work at 8:45. So that's kind of the end goal, maybe, possibly. I'm just kind of thinking here. I've basically tried this. I basically thought about this problem new every time I've done it, which is kind of a scary way to do things. But so I'm just kind of thinking about this. It says you need to be at work by 8:45. What is the probability that you will be there by 8:45, that you'll make it to work on time?
Okay, well.
Well, let's think about this. You're showing up here. If you get there right when the train does, and the train's ready to leave right when you leave, isn't it just going to be 18 minutes? And you're going to be early, aren't you?
Yeah.
You're going to be early by quite a bit. Well, maybe you just wait like 5 minutes, and then the train comes. It only takes you 18 minutes. You're still going to be a little early, aren't you? So the question is what's the latest the the train can get there and you still have enough time to get to work. Well, how long's the train ride?
18 minutes.
18 minutes is the train ride. So what time does that put us
27.
having to leave? Yeah, so basically you're gonna go 8:45 minus the 18 minutes, right?
27.
Which means at 8:27, we have to leave. So 8:27 is the latest we can wait to get there on time. Anything beyond this is no bueno, right? Anything beyond 8:27, we're gonna be late.
Basically, just start sprinting there.
Yeah, you try to like say, get out and push, maybe, yeah. Well, so ladies and gentlemen, how long could you wait and still get there on time?
12 minutes.
How long is that?
12 minutes.
12 minutes? So for 12 minutes here, that's your favorable outcome, isn't it? That's your favorable outcome. So what's the total wait that you might have to do? The total's 30, isn't it? So if we're gonna get the probability that you are on time, the probability you are on time is gonna be the amount of favorable minutes, which is what? 12 minutes divided by the total that it could be, right? Divided by 30 minutes. Does that reduce?
2/5.
What is it?
2/5.
2/5? And it's usually helpful to think of it as a decimal. What would be the decimal? 0.4. And it's also helpful to think of it as a percent. So what's the percent chance that you'll be on time? 40%. So it's kind of a geometric probability if you think about time as a number line, basically.
How did you get 12 minutes?
Oh, because the latest you could leave is 8:27. You get there at 8:15. So there's 12 minutes that you can wait and still be on time. After that, your wait is making you late.
That makes sense. Just I plugged that in my calculator the first time and it did not give me 12.
What, 8:27 minus 8:15.
15, yeah. It gave me 6 the first time. I
Interesting.
must have plugged it in wrong.
Yeah, that happens. You got a question there, Mr. West? Mr. West?
No, I'm just checking.
Are you good?
Yeah.
Yeah, so kind of an interesting problem. You're not gonna be asked to do this on a test or a quiz, but it's kind of interesting, I guess. Something that's kind of funny is, if you're in the math world, it's funny how train jokes are always used as like the punchline of like different math jokes. Turns out train ones are always the difficult questions.
Yeah.
And yeah, so if you found this difficult, you're not the only one. It turns out train questions are notoriously difficult. Well, we got one more to do, don't we?
Yeah,
Looks
I
like
do,
it.
yes.
That looks like a geometry problem, doesn't it?
Sure does.
I mean, really. All right, so example 5 says, find the probability that a randomly chosen point in the figure will lie in the shaded region. So we want the probability that a point chosen at random is shaded. Well, let's think of a game plan before we actually start punching numbers in. How are we gonna do this problem?
Well, it's a square.
We need to find the area of the square, aren't we? definitely gonna be a part of it. We're also gonna need what?
Mm,
We're gonna find the area, the square, and the circle. What are we gonna do with those, Ocean?
Yeah, put them, it's gonna be the square over the whole circle with the square in it, and then.
So I agree that it's gonna be over the whole circle. And isn't that gonna be pi 4 squared? That's a radius, isn't it?
Kind of the gray bit above it.
So the gray above it is gonna be the area of the whole circle minus what?
Oh, the square.
The area of the square. And I said we were doing a game plan, but then I start writing numbers.
I
Oh,
know,
really?
that's why I was
Yeah,
confused.
here, okay, so yeah, basically we're gonna do circle area. This is what I meant to do just now. Circle area minus square area. Divided by what? Circle area, cause isn't circle the whole thing? That's our game plan. I left this blank though because if we were given a side length, I would know this right away, wouldn't I?
Yeah, we would.
Are we given a side length?
No, but we
We're
are
not.
given the radius.
We are given a radius.
You can do the.
Yeah, we can do the thingy, can we?
There's a few ways to do this. I'm hearing 2 ways for sure that you can do this. Sammy mentioned a diagonal. Ocean mentioned a rhombus.
I wanna find the interior central angle, but
Oh, okay.
I did that and it gave me like a whole bunch of ones.
Oh, okay. So now I'm hearing the third way you can solve this. So we've got a square, right?
Yeah.
We know it's a square because if this is a circle, all these measurements, isn't this radius gonna have to be the same here?
Yeah.
Quadrilateral.
Everything's gonna be the same. So a square is a rhombus. And if you think of it as a rhombus, you can use area equals what, Sammy?
half of one times diagonal.
You got it. You got it. So we could totally do that because could we easily get the diameter? Oh yeah, couldn't we? What would the diameter be? I mean diagonal, I'm sorry. The diagonal would be 8. It's actually both, isn't it? So the diagonal would be 8 and they're both 8 and we're gonna be in business real quick. Well, a square is also a regular polygon, isn't it?
Uh-huh.
And with a regular polygon, we can do the formula 1/2 what?
You've lost me.
It's what our last quiz was over?
1/2 AP.
1/2 AP, yeah.
Oh, 1/2 apothem perimeter.
We would need the apothem and the perimeter. Do we know the apothem?
No. We can
Could we
find
probably
the-
figure it out?
That would take a really long time.
Oh, I don't know. I mean, it'd take a little bit.
For the whole
do,
thing.
do we know the perimeter?
No.
No, but could we probably figure it out similar to how we figure out the apothem?
We sure could.
We sure could.
Wouldn't the area be
Rhombus
faster?
seems like it would be easier though.
Oh, totally.
Yeah.
Okay, a third way that I thought to do it is, don't you find the area of the square by just doing a side squared?
Yeah.
And that would involve, I mean, you could totally do it this way, right? With that apothem, and once you get this, wouldn't you double it to get a side length and then square it? But you could also do one of these right here and make a big 45, 45, 90. And you could get the side length pretty quick. If the legs are 4, what would this side have to be?
Oh my gosh, you're right.
It would have to be 4 square root 2. So in that case, we've got some options here, don't we? We've got some options. I have a favorite in that this one is,
Yeah.
to me, the easiest. This one's a close second though, isn't it?
Yeah.
Squaring this, wouldn't you square the 4 and then square the square root and make it 4 squared times 2?
Yep.
So 4 squared times 2 is actually 32. 1/2 8 times 8 is what? 36, half of 64, which is 32. And we're not doing it, but if we were to do the regular polygon, we would have the 4, and then with it being a 45 here, you would do 4 divided by square root 2, rationalize it, multiply by square root 2 over 2, get 4 square root 2 over 2, which is 2 square root 2. That is your apothem. And also, if it's half of your side length, so double it, you get 4 square root 2. And then how many sides do you have? There's 4 sides. So there's 3 ways to do this. And for some reason, I decided to confuse all of you by showing you every single
Your
one.
computer will not.
Isn't that great teaching?
Yes.
It's great teaching, isn't it? So what I say is, in this time that you have left here, if you didn't write all this down, which I totally understand, just pick one that you like and go ahead and work it out that way so you have a good example in your notes. Sound like a plan? And I'll finish working it out so we'll all agree on an answer.
Oh, I hate this calculator.
Or did you want me to check your answer?
Well, no, I was wondering, since you didn't simplify it at the end, if you could simplify it, but you can't.
So, you can't simplify it and leave your answer, okay, in terms of pi, you're basically done. I mean, you would rewrite 4 squared as 16 pi, and then this is 16 pi, but because 16 pi doesn't reduce with 32, you're kind of stuck. So the exact answer is basically this. So it'll really make more sense when you're dealing with probability in this case to get a decimal answer.
Okay.
Yeah. What's up, Ocean?
You basically offered to check yours, so I was wondering if you could check mine.
Oh, okay. Let me double check the answer real quick.
Okay.
Oh, goodness.
Oh, I understand, yeah. Yeah, I agree, totally agree. Yep. Sweet. I concur. So which way did you decide to do? Side. Okay. Yeah, I guess I'll check you if you wanna get checked. You're going with this pop. Yeah.
Yeah.
Because he wants 3 decimal points at the end, so
Oh,
then you can make it
so
percent.
I was just using your calculator as well, and I did 16 times pi.
These don't simplify, do they? Oh, should they? What? Do they simplify?
No, it's gonna be the significant.
Yeah. How's it
The
going?
equals about 36.3%.
Yeah.
Oh, wait, we were doing
I don't know how much coming out negative. What? Yeah, that's why I'm confused.
Oh, okay, so
Show me your
I think
paper.
I didn't.
Is your paper?
Would you try
Yeah.
not to round until the very end and see if it come out?
Did I add 32? We're supposed to subtract 32, right?
Oh, yeah.
Yeah.
What?
So you, yeah, you two are totally done it, right?
Okay.
But
You made one?
I would just see if you can figure out ways to put it on. You don't have to round it. Oh, shut up.
He's gonna give you his keys to which
Oh, poor guy.
Look.
Got some problems.
Yeah.
I think we'll do it.
Yeah, I think so.
What?
Oh shit.
Did you just did you not just plug in 18.265 divided by 15.265?